Nuclear reactor. In this video, we are going to learn about the nuclear reactor. Nuclear reactors are the modern-day devices extensively used for power generation, as the traditional fossil fuels like coal are at the brink of extinction. A nuclear reactor is the source of intense heat which is in turn used for generation of power in nuclear power stations. Its mechanism is similar to that of a furnace in a steam generator. The steam is used to drive the turbines of the electric generator system. A nuclear reactor consists of three crucial components: fuel elements, moderator, and control rods. Fuel elements come usually in the shape of thin rods of about 1 cm in diameter and contains fissionable nuclei like uranium-235 or uranium-238. These rods vary a number according to the size of the reactor. In large power reactors, thousands of fuel elements are placed close to each other. This region where these fuel elements are placed is called the reactor core. These fuel elements are normally immersed in water which acts as a moderator. The objective of a moderator is to slow down the energy neutrons. A nuclear reactor which are produced during the nuclear fission process by the fuel elements thermal neutrons, which are the neutrons with energy of about 0.04 electron volts, are capable of producing fission reaction with uranium-235. Burning the fission reaction process, new neutrons are given out which have energies of about 1 mega electron volt. This is 1 mega electron volts. These neutrons typically escape from participating in another fission process as they are accompanied by enormous energy release. In fact, the probability of these neutrons produce another fission reaction is 500 times less than that compared to a thermal neutron. This is where a moderator is extremely useful. Moderators have the capability to slow down, or in other words, moderate the speeds of these high-energy neutrons so that they can in turn be used for a chain reaction to trigger multiple fission reactions of other uranium-235. Nuclei, commonly ordinary or heavy water, is used as a moderator in nuclear reactors because of the neutrons present in them which are capable of slowing down the neutron speed. Water molecules in the moderator are useful in slowing down the high-energy neutrons which leave the fuel element after the nuclear fission. These high-energy neutrons collide with water molecules, thereby losing out on some energy with every collision and therefore slowing down substantially. A new fission reaction can now be triggered using this slow neutron by striking it with a fuel element. The third and most prominent part of a nuclear reactor are the control rods. In order to get a steady output of energy from the nuclear reactor, every single fission reaction should trigger another fission reaction and ensure the availability of spare neutrons released to trigger the chain reaction. By controlling the number of spare neutrons available at any given time, the rate of nuclear fission chain reactions can be controlled. This control on the fission reaction can be maintained using control rods. The main function of the control rods is to absorb any excess or spare neutrons in the moderator in order to prevent any further fission reactions. Usually, such control rods are made of boron or cadmium. To increase the rate of fission reactions, these rods can be removed from the moderator. A steady output of energy can be maintained by inserting or removing the control rods in the nuclear reactor. Now that we know the components of a nuclear reactor, let's understand the working of a nuclear reactor. It is usually enclosed in a shield made of thick concrete walls. It consists of a reactor core pump and heat exchanger. The reactor core and the pump are placed in contact with the water, which is usually the heat exchanger in these reactors due to the enormous amount of heat released during the fission reaction. The surrounding water gets heated up and changes to steam, which is in turn used to turn the turbine, so huge heat energy gets converted into electrical energy. Water is continuously flown in and out of the nuclear reactor using the pump, so a nuclear reactor successfully generates a nuclear energy from fission reactions.
At the surface, concept of fusions and fissions have been considered for hundreds of years. In the past, it was called alchemy, but the goal here not to turn charcoal into gold. Fusions and fissions would build up or break down of an atom. Fusion is when two or more nuclei combine to create a nucleus of greater mass. All elements exist because fusions form hydrogen atoms created larger atoms up through length. Stars are powered by fusions, creating helium and other elements, and supernovas create the heavier elements. Fusions requires very high temperature in order to occur. We are talking over 40 million degrees Celsius. Let's look at a reaction that occurs in the Sun. Deuterium is an isotope of hydrogen with 1 neutron, and tritium is an isotope of hydrogen with 2 neutrons. When they collide under high temperature conditions, they form a helium atom. They release a neutron and they release a huge amount of energy. Now, fusions require temperatures that are very high and very difficult to attain, and the reaction itself is nearly impossible to control. To get the high temperature to start the reaction, we need something like a nuclear bomb, and once that's gone, good luck trying to control it. Fissions is in a small part the opposite of fusions. It's the splitting of a nucleus into smaller fragments by the release of neutrons and lots of energy. But nuclear fusions will only happen when two neutrons hit one of two fissionable isotopes, uranium-235 or plutonium-239. First, a neutron hits uranium-235, which makes it so unstable, breaks into two smaller. The chain reaction is where fusions really we can harness the energy released from fusions, which much more easily than harnessing fusion's energy. Nuclear reactors are the heart and the soul of nuclear power plants. We use controlled ignition in fuel rods that are cooled by a coolant fluid, usually water. The heat from the core is used to generate steam, which will drive the turbine that creates electricity and a generator. The large tower that you may use to seal up actually just for cooling down and condensing the water so that it can be released in the system. There's no radioactive material in those cooling towers, just steam. The fuel rods are made of a metal which contains uranium-235 or plutonium-239. When the fuel rod is low in fissionable atoms, it is considered to be spent, used up. Spent fuel rods are still radioactive zones. They must be placed underwater in holding tanks to cool them down, and the water also acts as a shield to reduce radiation level. Now, perhaps most notoriously, fissions and fusions can be used in nuclear weapons. The fission bomb, also known as the atom bomb, includes weapons whose explosive output is exclusively from fission reactions. Many fission bombs have been dropped to test and study their power and nuclear fallout.
Trace, it's your turn to take out the nuclear waste!
Oh man, I don't even know where to put it. Hey there friends, welcome to D-News and thanks for tuning in. I'm Trace. Nuclear energy is controversial to say the least. Those who are for it say that it can provide relatively cheap, safe and clean energy. Those against it point to expensive plants and fuel, plus the storage of the spent waste. Then when accidents do happen, they're visible, devastating and deadly. So nuclear's got a lot going on. Regardless of whether you're for or against it, everyone can agree nuclear waste is a troubling issue. Recently, at the Waste Isolation Pilot Plant, or WIPP, in New Mexico, a radiation alarm went off. Someone screwed up. 15 years ago, WIPP became the first and only permanent geologic nuclear waste storage facility in the country. But now, The Verge is reporting substandard kitty litter might bring the whole place down. Back in February, part of the place had to be shut down, the air vents were permanently blocked with high-density expanding foam, and people were evacuated. The problem was kitty litter. someone packed nuclear material in organic kitty litter, which is made of wheat or corn, rather than the inorganic type that they almost always use. That tiny change caused one of the waste barrels to burst, releasing radiation and setting off alarms. I didn't realize they packed nuclear waste in kitty litter. That's pretty weird. When you hear nuclear waste, you probably picture a soupy, glowing green liquid like you see in The Simpsons or Futurama. In real life, nuclear waste can be any number of things, from tools and parts from nuclear plants to spent uranium fuel rods or pellets. Seriously, after too many wearings, even the uniforms they wear in the plant are put into nuclear waste barrels. According to the Department of Energy, the United States has 75,000 metric tons of spent nuclear fuel. The waste is stored at 122 temporary sites in 39 different states, but only WIPP is, and maybe was, the only permanent site in history. So since we're obviously not throwing it at the sun, what the heck are we doing with this stuff? Well, there are ways to reprocess the radioactive spent fuel rods to remove plutonium for use in warheads, but due to fears about nuclear weapons proliferation, nobody really wants to do this. Another thing is to burn the waste in fast neutron or traveling wave nuclear reactors. They're different kinds of plants that create energy from the remaining atoms and further reduces the final waste product. But there's still that kicker. There's a lot of nuclear waste still at the end of the line. No matter what we do, our best option right now is called deep geological disposal. Basically, we're burying it. Though even how to do that is debated. At the moment, WIPP is the best plan, but others include drilling almost 2 miles into the earth and leaving the stuff down there forever. And there's also an option to put it into shale or salt mines. WIPP is a dry salt bin, after all. They dig down like a mine, and then they dig out areas that they can keep those barrels of nuclear material in for the next tens of thousands of years. So which do scientists prefer? They don't know. They're not actually sure. Most are concerned with groundwater contamination, earthquakes, cave-ins, and other problems with underground excavation. At the moment, there are a few places where the conditions are just right, and they're not concerned about these things. But considering we've got 104 nuclear reactors generating waste in the US alone, the problem is mounting. So what would you do with nuclear waste? Contaminate the comments with your thoughts and subscribe for more D News every day.
One of the many fields that use nuclear technology is medicines. This technology has been a part of our healthcare system since 1950s. Hospitals use substances called radioisotopes to see inside the body. It's kind of like creating a map of your internal organ. This map can help doctors detect and diagnose illness. When you have a diagnosed nuclear, technology can also treat you. For instance, radiation therapy can battle and cure illness such as cancer. The therapy targets the unhealthy cell in your body, allowing the rest to stay healthy. These treatments are done on a daily basis in hospital and healthcare clinics. In fact, radioisotopes are used in over 5,000 procedures every day and help save a number